of that switch should be, for example, at least equal to the total power of the need of your devices. Also, in some switch ports, we don't have the capability of PoE. For example, maybe you are buying one switch. In this switch, we have 24 interface, 24 ports, okay? But only 12 ports of this switch support the PoE, and other ports doesn't support the PoE. We can say 12 ports are PoE or power over Ethernet capable, and 12 ports, okay, are non-PoE. This means that you cannot connect to these ports the PoE devices. Because of that, you need to consider the number of switch ports in your device that support the, for example, power over Ethernet. Also, the switch power supplies, this is exactly the same thing that I have explained before. You need to consider that this switch is a PoE capable, and also the total power of this switch is, for example, sufficient for your requirement. For example, here, look at here, in this switch, when you are using show power in line, you know that until now we have used only 10 watt of power. Here we have available power. This is the total power, or maybe the default power that we have in this switch, 370 watt. Because we have used 10 watt, only 370 watts of power now is remaining. Because of that, you need to consider the total power that you need in your network. And also we need to for example, consider the PoE standards, means IEEE 80380, 3AF, and also 3BT, okay? And after that, you can choose the correct standard, the correct switch capabilities for your device. For example, I have a device with requirement of the IEEE 803BT, okay? And because of that, we need to buy a switch with the capability of the UPoE at least or UPoE plus. Here you can see PoE standard versus actual. What is the meaning of the actual power requirement? You know that, for example, we have a switch with the, for example, PoE capability, means 15 watts, okay? This is a switch. The port of this switch can supply the power, the 15 watt, but our device, our PD, only needs 7 watt. It's okay. We can apply less than or lower than the maximum available power on one port. Okay, it's okay. And with the negotiation with the CDP and LLDP, the switch can find which amount of power is suitable for the device. After that, this negotiation should be occurring during the time. If the requirement was changed, again we should apply maybe the other amount of, for example, power over Ethernet. Here in the packet tracer, you can connect the device, for example, PSE, to multiple switches, to multiple, for example, PoE devices. One of them is IP phone, and let me to find another devices here in the wireless. Okay, we have some, for example, access point. This is the access point. Let me to connect the AP. In the AP here, now we have the connectivity to the power. It has power. And also in the lightweight AP, this is the lightweight access point. Here we have adapter. Let me to connect this lightweight access point, okay, to the, for example, switch. This is the PSE switch. I'm going to connect it to the lightweight access point. As you saw, I didn't connect the adapter to the access point. Now in the PSE, if you check the show power in line, okay, show power in line, you can see that this access point now is using 15 watt, but the, for example, IP phone is using 10 watt. Here we can see the class of the, for example, class of the IP phone, and the here you can see the maximum power available in each port of the PSE. You know that this switch is a PoE, and PoE can support 15.4 maximum power. And as you can see, the iPhone is using 10 watt, and the access list is using the 15 watt. Or maybe you have another device that needs a lower amount of power, and because of that we don't have any problem, because the switch can apply lower power, but the switch cannot apply more than 15 watt in one interface. Don't forget, if you attach, for example, one device with the requirement of the 30 watt power to one interface, that device cannot work and the device cannot be enabled. Okay, this is the PoE in the CCNA, in the level of CCNA, but let me to emphasize that about the PoE, we will learn more than this in the future. PoE is not a concept, PoE is a tool, and we are using the PoE, okay? PoE is different with the, for example, STP and some other concepts. PoE is a feature that we need it, okay, for using the network is more easier and also more efficiently. With PoE you can easier manage the for example, power in your network, and the cost of the supplying power for the devices will be reducing. Very good. In this video we have learned about the LAN architecture. You know that I have explained the campus LAN topologies and also the SOHO network, and after that finally we have learned about the PoE or power over Ethernet. In the next video I'm going to talk about the WAN architecture. This is the LAN architecture, means local area network architecture. In the next video we will learn about the WAN or wide area network architecture. In this video we didn't configure anything, it's okay, but it's important to understanding the concept of this video for learning the WAN architecture. Because of that, first review all of the content of this for example video. After completing all of the concepts, if you want you can take some notes, you will be ready to learning about the next step, the WAN architecture. You know that in one enterprise we have LAN and also we have WAN. Now we have for example view about the LAN architecture. Let me to talk about the WAN architecture in the next video. Because of that, after reviewing all of the concept of this video, please come with me to the next video. I'm going to talk about the WAN architecture.